Now, the ninth thing that we'll decide in a graph is whether the function is a continuous function or a discontinuous function. So, if the graph of a function is connected, then we'll say the function is continuous. And if the graph of a function is disconnected at any point, then we'll say this function is discontinuous at that point. So in order to decide whether the function is continuous or discontinuous, all you need to do is you need to draw the graph. And if while drawing the graph, my pen lifts, then the function is discontinuous at that point. And if I don't need to lift my pen, then the function is continuous. Say for example, now this function f is defined from R to R. Now I need to know whether this function is a continuous function or a discontinuous function. So if I'll try to draw this graph again, I don't need to lift my pen, right? So that means I'll say this function is continuous for all real numbers. So this is continuous in all x belongs to R. Now what about this one? Now if I'll try and draw this graph, my pen, it is going to lift at x equals to 0. And if I'll draw it again, now again my pen is going to lift at x equals to 4. So that means this function is discontinuous at x equal to 0 and x equal to 4. Now the 10th thing that we'll decide in a graph is its differentiability. Whether a function is differentiable or not differentiable. Now for differentiability, there are two steps. Now step number 1, discontinuity implies non-differentiability. If function is discontinuous at some point, I'll straight away say this function is also not differentiable at that point. Now second thing is, what if a function is continuous at a point? If function is continuous at a point, I'll need to check its differentiability. If at any point the function changes smoothly, then the function is differentiable at that point. Now if a function has sharp corners or a cusp or a point where it has a vertical tangent, then so at that point the function will be continuous but it won't be differentiable. So in differentiability, what exactly we are looking for? At any point, say at x equals to a, if I'm to approach this function from the left hand side and I draw a tangent, and if I draw the tangent on the right hand side, and again if I approach this point, if I get both the tangents same, then I'll say the function is differentiable. If I have a point where left hand tangent is different than a right hand tangent, then I'll say this function is not differentiable. Now in this case also, so now this is tangent on the left and this is tangent on the right. So this again is not differentiable. Now at this point, I get a vertical tangent, and vertical tangent slope is infinite. So then again, this function is not differentiable. Say for example, so suppose this is the graph which is given to me. Now when I look at this graph, I know if I'll draw this graph, my pen is going to lift at 0. So it is discontinuous at x equal to 0. So this function is discontinuous at x equal to 0, but at all other points, this function is continuous. So there is only one point where this function is discontinuous. Now, when we talk about differentiability, clearly I know because at 0, this function is discontinuous. It is not differentiable at x equal to 0. Now I see an edge at -2 and +2. So because I see two different tangents at -2 and +2, this function will also not be differentiable at x equals to -2 and x equals to +2. So this function is discontinuous at x equals to 0. And this function is not differentiable at x equals to 0, x equals to +2 and x equals to -2. Now I'll take up another example. Now what about differentiability of this function? So I can draw this graph without actually having to lift the pen. So that means I can say this function is continuous for all x belongs to R, but it is not differentiable at x equals -1, 0 and +1. So we can decide continuity and differentiability from the given function. Now if we look at the second question, which is we are given this function fx, and fx is defined as mod of
2x minus 3 into greatest net function of x if x is greater than or equal to 1, and it is sine pi x by 2 when x is less than 1. Now we need to discuss continuity and differentiability of fx in the interval 0 to 2. Now what we'll do is we'll write this fx as sine pi x by 2 when x lies between 0 and 1. Now when x lies between 1 and 2, in that case greater function of x is 1, so it will be this mod of 2x minus 3, and when x is 2, this value will be 2 into 1, which is 2. Now we'll draw the graph of fx. This is 0, 1 and 2. Now first we'll draw the graph of sine pi by 2x. Now for sine pi by 2x, what we need to do is we just have to draw the graph of sine x. So it is 0, this is pi, this is 2 pi, and we have to divide everything with pi by 2. So we divide everything with pi by 2. This point is 2, this is 4, and here it is 1. So from 0 to 1 will be this graph. Now when x is 1, this mod of 2x minus 3 will be 1, at 3 by 2 will be 0, and at 2 will again be 1, at 2 it is 2, so at 2 this value is 2. Now this function is discontinuous at x equal to 2. So in this interval from 0 to 2, there is only one point x equals to 2 where this function is not continuous, and this function is not differentiable at 1, 3 by 2 and 2. So it is not differentiable at x equals 1, 3 by 2 and 2, and that is the answer to this question. Now here we are given this function fx, which is defined as x square minus 2 mod x. Now gx is defined as minimum of fx in minus 2 to 0 and maximum of x from 0 to 3. Now we'll draw this graph, and for this we'll start with the graph of y equals x square minus 2x. Now graph for this function is roots are 0 and 2, and this is 1, and at 1 this value is minus 1. Now we'll take the transformation of mod x. So it will be x square minus 2 mod x. So we'll erase the graph from second and third quadrant, and then we'll take the reflection of left on right. So this function, it will be drawn like this. Now this is 0, this is 2, this is minus 2, this is minus 1, and this is plus 1, and this value here is minus 1. Now it says when x lies between minus 2 and 0, gx is minimum of ft. Now between minus 2 and minus 1, since this function is decreasing, its minimum value will always occur at the end of the interval. So from minus 2 to minus 1, gx is simply fx. Now in between minus 1 and 0, minimum value will always be at minus 1, which is minus 1. So this is going to be the graph of gx when x lies between minus 2 and 0, and here 0 is not included. Now it says maximum of fx from 0 to 3. Now at 0 this value is 0, and here it is a decreasing function. Between 0 and 2, maximum value is going to be the value at 0. So from 0 to 2 it will be this straight line, and then from 2 to 3 this function increases, and that is it. So this blue graph is the graph of gx. Now at how many points gx is discontinuous in its domain? It is only at 1 point. And at how many points it is not differentiable? It is not differentiable at 0 and 2. So at 2 points, and that's your option C. So the correct options are B and C. Now in the questions we are given two functions, fx, which is mod of x plus 1, and gx, which is x square plus 1. And we have defined hx as maximum of fx gx if x is less than or equal to 0 and minimum of f and g if x is greater than 0. Now we'll solve this question using graphs. Now we'll draw the graph of fx and gx. Now fx is mod x plus 1. That means we have to take the graph of mod x and shift it 1 unit along y-axis. So we'll take the graph of mod x and we'll shift it 1 unit along y-axis. So that's the graph of y equals mod x plus 1. Now this branch is x plus 1 and this is minus x plus 1. And then we'll draw the graph of gx equals x square plus 1. Now if we equate them, then we can write x square plus 1 equals mod x plus 1. From here we'll get mod x equals 0 and mod of x equals 1. So these two graphs, they'll intersect at 0 and plus minus 1. So if we draw the graph of gx, it'll be basically this graph. Now we look for hx. Now hx is maximum of fx and gx if x is less than or equal to 0. So in this interval, whichever is higher, that's our hx. So we'll choose this graph and then we'll choose this graph. And this point is minus 1 and this point is plus 1. Now when x is greater than 0, we need to find minimum. So here minimum is this graph and it is this graph. So this function is continuous in x belongs to R, but it is not differentiable at x equals minus 1, 0 and plus 1. So number of points at which hx is not differentiable is simply 3. Now here the question is, we are given these two functions f and g, where fx is defined as mod of 2x minus 1 plus mod of 2x plus 1, and where gx is x minus the greatest integer function of x, which is basically fractional part of x. Now f is defined when x lies between minus 1 and plus 1, and so is g from minus 1 to plus 1. And f of gx is this composite function. Now suppose c is the number of points in the interval at which f of gx is not continuous, and suppose d is number of points in the interval at which f of g is not differentiable, then find the value of c plus d. Now basically f of gx is two times fractional part of x minus 1 plus mod of 2 times fractional part of x plus 1. Now we clearly know that fractional part x function, it is periodic function with period 1. So what we'll do is we'll try and find this function when x lies between 0 and 1. Now when x lies between 0 and 1, then basically fractional part of x is simply x. So in that case, this f of gx will be same as fx, which is mod of 2x minus 1 plus mod of 2x plus 1. Now if we draw this graph between 0 and 1, now at 0 this value will be 2. So at 0 this value is 2 and 2 is included. Now at 1 by 2 we have this value as 0 and here this value will be 2, and at 1 this value is going to be 4. So that is the graph of f of gx in 0 to 1, and since it is a periodic function, in between minus 1 and 0 we'll repeat the same graph. And this point is minus 1 by 2 and this point is plus 1 by 2. Now number of points in open interval minus 1 to 1 where this function is discontinuous, it is discontinuous only at x equal to 0. So basically value of c is 1 and the number of points at which this is not differentiable is 1, 2 and 3. So value of d is 3. Now we need to find the value of c plus d. The value of c plus d is simply 4, and that is the answer to this question. Now here the question is, examine the differentiability of this function fx, which is mod x plus mod x minus 1 plus mod of x minus 2. Now for this question, we can see that it is a sum of linear functions of modulus function. So whatever the interval, it is just going to be a line segment. So what we'll do is we'll start drawing this graph. Now we have three critical points, 0, 1 and 2. So we'll find the value at 0. If x is 0, this value is 3. If x is 1, this value is 2. And if x is 2, this value is 3. Now if we put x as minus 1, we'll get this as 1 plus 2 plus minus 3, we'll get this as plus 6. So it will be this plus 6, and here also at 3, it will be this plus 6. Now if we join these points, that is the graph of this function. Now this function is not differentiable at 0, 1 and 2. So it is continuous in x belongs to R, but not differentiable at x equal to 0, 1 and 2. Now in the questions, we are given this function fx, which is defined as minus 1 when x lies between minus 2 and 0. And this is x square minus 1 when x lies between 0 and 2. And then we have this function gx, which is mod of fx plus f mod x. Then in the interval minus 2 to 2, g is what? Now first we'll draw the graph of fx between minus 2 and 0. This is minus 1, not included at 0. And between 0 and 2, this is x square minus 1. So this is x square minus 1. So that is the graph. So this is minus 1 and this is x square minus 1, and this point here it is 1. So this is y equals fx. Now if we take the transformation of y equals mod fx, then we'll reflect the graph about x-axis in the upper direction, and then we'll erase the graph from third and fourth quadrant. So it'll be this graph, and here it will be inverted like this. So between minus 2 and 0, this is 1. Here it will be x square minus 1, and here it will be minus x square minus 1. So that is the graph and definition of mod fx. Now we'll draw f mod x. Now for f mod x, we erase the graph from second and third quadrant, and then we take reflection of right or left. So on the right we have this x square minus 1, and if we take its reflection on the left, it will be x square minus 1. So f mod x is simply x square minus 1. Now we can write the definition of gx. When x is less than 0, this is 1 and this is x square minus 1. So if we add them, it will be this x square. Now between 0 and 1, this is x square minus 1 and this is minus x square minus 1. So it will cancel, it will be 0. And when x is greater than or equal to 1, it will be x square minus 1 plus x square minus 1. It will be 2x square minus 1. Now since both the functions, they are continuous, this function gx, it is continuous at minus 2 to 2. Now we have to check its differentiability. Now we find g dash x, it will be 2x when x is less than 0, and it will be 0 between 0 and 1, and it is 4x when x is greater than 1. Now at 0, it is differentiable because 0 negative is 0 and 0 positive is 0. So it is differentiable at x equal to 0, and at 1, its left hand derivative is 0 and right hand derivative is 4. Not differentiable at x equal to 1. So answer is not differentiable at 1 point, and that's your option A.
Discuss the differentiability of the function y equals mod of 1 minus mod of 1 minus mod of 1 minus mod of 1 minus x. So we'll draw the graph of this function, and from the graph we'll work out differentiability of this function. So my basic graph here is y equals 1 minus x, which is a straight line. So when x is 0, y is 1, and when y is 0, x is 1. So that is the graph of y equals 1 minus x. Now I'll take the transformation of y equals mod fx. So mod of 1 minus x. Now transformation of mod fx is mirror on x-axis, take the reflection of down on up, and then erase the graph from third and fourth quadrant. Now I'll take the transformation of y equals minus mod of 1 minus x. So transformation of minus fx is rotate the graph 180 degrees about x-axis. I'll take the transformation y minus 1 minus mod of 1 minus x. So I'll need to shift the graph plus 1 units along y-axis. Now next again, I'll take mod fx, so which is 1 minus mod of 1 minus x. Now again I'll take the transformation. Then again I'll shift it. Now again from here, y equals mod of 1 minus mod of 1 minus mod of 1 minus x. So minus 1, 0, 1, 2 and 3. Now we'll just need to do that one more time. And then finally, transformation of another mod of x. So this is minus 2, minus 1, 0, 1, 2, 3 and 4. Now it is continuous for x belongs to R, but it is not differentiable at these points. So it is not differentiable at minus 2, minus 1, 0, 1, 2, 3 and 4. Discuss the continuity and differentiability of the function fx equals greatest integral function of x sin pi x when the value of x lies between minus 1 and 1. So what I'll do is I'll draw the graph of y equals sin pi x. So I'll draw the graph of sin x. Now for sin pi x, I'll divide every value with pi. So now here it will be minus 1, 0 and this one will be plus 1. So I'll take two separate cases. Case 1, when the value of x lies minus 1 and 0. When x lies between minus 1 and 0, in that case, the value of sin x will also lie between minus 1 and 0. So here I can say the value of sin pi x will also lie between minus 1 and 0. Now if I'll multiply them, then when I'm multiplying two negative numbers, I'm bound to get a positive number. And because numerically their value lies between 0 and 1, so still their product will also lie between 0 and 1. So this value will lie between 0 and 1. So if I'll take their greatest integer function, so I'll write x sine pi x, this value will always be 0. So when x lies between -1 and 0, the value of greatest integer function of x sine pi x is 0. Now I'll take the second case. Now second case, when the value of x lies between 0 and 1. So when x lies between 0 and 1, the value of sine pi x, it will also lie between 0 and 1. So it will lie between 0 and 1. Now if I'll multiply it, I'll get this value as x sine pi x will always be greater than or equal to 0 but less than 1. It will be less than 1 because in order to achieve the value 1, for both of them, they have to be 1 simultaneously. But they are not 1 simultaneously at one point. So this value will always be less than 1. So in this case also, greatest integer function of x sine pi x is 0. So the given function fx in the interval -1 to 1 is nothing but a constant function which is 0. And any constant function in an open interval is both continuous as well as differentiable. So answer is, this function is continuous and differentiable in -1 to +1.
Now here the questions. We are given this function fx which is defined as maximum of minus mod x and minus under root of 1 minus x square. Now if we look at this graph, which is y equals minus 1 minus x square, it is x square plus y square equals to 1, and this minus sign it represents, we are talking about a semicircle which lies below x-axis. So this is the graph of minus under root 1 minus x square when x lies between -1 and +1. Now we have to draw the graph of y equals minus mod x. Now this is the graph of y equals minus mod x. Now we have to choose maximum of the two. Maximum of the two. Now in between -2 and this point, maximum is this graph. Now between 0 and this is maximum. And here again, this is maximum. Now it is not differentiable at these 3 points. So f is not differentiable at 3 elements, and that's your option A. Now here the questions. We are given this function fx which is maximum of mod x and x square when mod x is less than or equal to 2, and it is 8 minus 2 mod x when mod x lies between 2 and 4. Now we need to find set of points in the interval -4 to 4 at which f is not differentiable. Now we'll draw this graph, and we have to draw it between -4 to +4. Now in between -2 and +2, it is maximum of mod x and x square. Now this is mod x, and then we have x square. They'll intersect at -1 and +1. Now we have to choose maximum of the two. So we'll choose this function, this and this. Now at 2, this value is 4. Now when x lies between 2 and 4, it is 8 minus 2x. So if we put x is 2, it will be this 4, and at 4 it will be 0. So it will be this straight line, and here also it will be this straight line. Now it is not differentiable at -2, -1, 0, +1 and +2, and that's your option A. Now here the questions. We are given some functions a, b, c, d, and we have to match them with p, q, r and s. Now in this A, we have this function fx as x into mod x. Now we can write this as minus x square when x is less than 0, and it is plus x square when x is greater than or equal to 0. Now we can draw its graph also. Now this is minus x square, and here it is plus x square. Now this A, it matches it is continuous in minus 1 to 1. With B, it is differentiable, it is strictly increasing. So A matches with P, Q and R. So this A, it matches with P, Q and R. Now this B is under root of mod x. Now this is under root x, and for mod x, we'll take its reflection. Now between minus 1 and plus 1, it is continuous. So this B, it matches with P. It is not differentiable at 0. It is not strictly increasing, and S is not differentiable at least 1 point. So this B, it matches with P and S. So this B, it matches with P and S. Now this C is x plus greatest linear function of x. Now between minus 1 and 0, this is x minus 1. So it will be this graph. Between 0 and 1, this is x. Now this is discontinuous, not differentiable, but strictly increasing and not differentiable at least 1 point. So this C, it matches with R and S. So this C, it matches with R and S. And finally, we have this option D, which is mod of x minus 1 plus mod of x plus 1. Now when x is greater than minus 1, this is x plus 1, and when x is less than minus 1, this is 1 minus x. So basically it is a constant function, and if it is constant, it is both continuous and differentiable. So this D, it matches with P and Q, and that is the answer to this question. Now here the question is, we are given these 4 functions and then we have to match them with the options given in column 2. Now we'll start with this first function, which is f1x. Now f1x is defined as greatest linear function of 4x upon pi into signum of x square minus x plus 1. Now if we look at this quadratic, x square minus x plus 1, d here is minus 3, which is less than 0, and coefficient of x square is positive. That means this is greater than 0 for all x belongs to R. And if fx is positive, then signum of fx is always 1. So this value, it is plus 1. So our function f1x is nothing but it is this greatest linear function of 4x upon pi. Now it is given that x lies between minus 2 and plus 2. Now we look at 4x upon pi, it will be minus 8 upon pi less than equal to 4x upon pi and be less than equal to 8 upon pi. Now 8 upon pi is nearly 2.55. So it will be minus 2.55 less than equal to 4x upon pi and will be less than equal to 2.55. Now this function, it will be discontinuous and non-differentiable at x equals 0, plus minus 1 and at plus minus 2. And range of this function, it will be this minus 3, plus minus 2, plus minus 1 and 0. Now we look for the second one. Now this second function we have is f2x equals cos inverse of signum cos 2x minus 1 by 2 into pi. Now we can write this as cos inverse and then signum of, now we write this as cos pi by 2 minus pi x, which is sin pi x. So this is cos inverse signum of sin pi x. Now we'll start drawing the graph of f2x from minus 2 to plus 2. Now this is minus 2, minus 1, 0, plus 1 and plus 2. Now Whenever x is an integer, this is sin n pi is 0, signum 0 is 0, and cos inverse 0 is pi by 2. At all these integer points, value is pi by 2. Now, when x lies between 0 and 1 and minus 2 and minus 1, sin pi x is positive. In that case, signum function, it is 1 and cos inverse 1 is 0. So, in between these two, value is 0. And when x lies between minus 1 and 0 and 1 and 2, sin pi x is negative. And signum of negative function is minus 1. Cos inverse minus 1 is pi. So, in that case, value of this function, it will be pi. So, that is the graph of f2x. Now, if we look at points where it is discontinuous, 1, 2, 3, 4, 5, we have 5 points where this function is discontinuous. And at those 5 points, this function is also not differentiable. And its range is 0, pi by 2 and pi. Now, f3x is maximum of fractional part of x plus 1 and fraction part of 5 minus x. Now, integer doesn't affect fraction part function. So, it will be this maximum of fractional part x and fraction part of minus x. Now, we'll draw this graph. Now, both these functions, they are periodic with period 1. So, we'll draw the graph in 0 to 1. Now, that's the graph of fractional part of x. And this is the graph for fractional part of minus x. Now, we have to choose maximum of the two. Now, here it will be this value, and here we have values at 0 and 1. So, at 2 also will be same. Now, this is minus 1 and minus 2 will be same here, and it will be same in this way. So, that's the graph of this function. f4x is mod x plus greatest new function of x square. Now, clearly it is discontinuous at 0, plus minus 1, plus minus 2, and f4x will be x when x lies between 0 and 1, when x lies between minus 1 and 0, and between 1 and 2, its greater function square will be 1. So, then it will be mod x plus 1, and in between minus 2 and minus 1 will be simply mod x plus 4. Now, if we draw this graph, between 0 and 1, this is x. Between 1 and 2, it is x plus 1. So, at 1, this value is 2, and 2, this value is 3. So, it will be from 2 to 3. So, this is 0, 1 and 2. Now, between minus 1 and 0, this is minus x plus 1. Now, at 0, this is 1, and at minus 1, this is 2. And here it will be this minus x plus 4. So, when x is minus 2, this is 6, and when x is minus 1, this is 5. So, it will be from 5 to 6. So, that is the graph of this function. Now, here the question is, we have defined this function fx as minus 1 when x is less than 0, and this is x minus 1 when x is greater than 0, and gx is f mod x plus mod fx. Now, what we'll do is, we'll draw the graph of fx. Now, between minus 2 and 0, this is minus 1, and at 0, this is minus 1, at 1, this is 0, and at 2, it is 2. It is a continuous function, so we may include 0 at any point. Now, this is minus 1, and this is x minus 1, and this point, it is 1. This is 2, and this is minus 2. Now, first we'll draw the graph y equals f mod x. Now, for mod x transformation, we'll erase the graph from second and third quadrant, and then we'll take the reflection of right on left. So, this f mod x graph, it will be this graph, and this graph. Now this is x minus 1 and this is minus x minus 1 in between these values, and its definition changes at 0. Now if we look at y equals mod fx, we'll take the reflection of down on up and erase the graph from down. So now this graph, it will be now this is 0, this is 1, and this is 2. This is plus 1. This is minus x plus 1, and this is x minus 1. Now we'll start writing the definition of gx. Now when x lies between minus 2 and 0, this definition is minus x minus 1, and this is plus 1. If we add them, it will be simply minus x. Now in between 0 and 1, this is x minus 1 and this is minus x plus 1. So it will be 0. And when x lies between 1 and 2, it will be 2x minus 1. Now this function is clearly continuous. Now we'll find g dash x. G dash x will be minus 1 when x lies between 2 and 0. This is 0 between 0 and 1, and this is 2 between 1 and 2. Therefore it is not differentiable at 0 and 1. So this function gx, it is not differentiable at x equals 0 and 1. And that is the answer to this question. Now here the question is, we are given this function fx as x cube minus x square, and I think here it should be this plus sign, plus x plus 1, and gx is max of ft when x lies between 0 and 1, and it is 3 minus x when x lies between 1 and 2. Now we look at this f dash x will be 3x square minus 2x plus 1. Now d in this case will be 4 minus 12, which is less than 0. That means this is always greater than 0. So this fx is an increasing function. Now if fx is increasing, then in this interval between 0 to 1, for any t which lies between 0 to x, maximum value of this function, it is going to occur at fx. So this entire definition, it is nothing but it is simply fx. So now we can write this gx as x cube minus x square plus x plus 1 when x lies between 0 and 1, and it is 3 minus x when x lies between 1 and 2. Now we need to find its continuity and differentiability in 0, 2. Now g1 negative is equal to g1, and it will be 1 minus 1 0, and it will be 2, and g1 positive is 3 minus 1, which again is 2. Now if we find g dash x will be 3x square minus 2x plus 1 when x lies between 0 and 1, and it is minus 1 when x lies between 1 and 2. Now here we can write g dash 1 negative as 3 minus 2 plus 1 will be 2, and g dash 1 positive is minus 1. So this gx, it is not differentiable at x equals 1. So in this interval it is continuous, but it is not differentiable at x equals 1. Now here the question is, discuss the differentiability of the function fx equals sine inverse 2x upon 1 plus x square. Now we have solved n number of questions like this in inverse trigonometric function. So here what we need to do is, we need to split the definition according to the values of x. Now for this, what we'll do is, we'll let x as tan theta, and if x is tan theta, then theta is tan inverse of x. Now, principal value range of tan inverse of x is from minus pi by 2 to plus pi by 2. That means value of theta is going to lie between minus pi by 2 and plus pi by 2. Now, if we put x as tan theta, this fx, it will be sine inverse, and this is 2 sine theta upon 1 plus sine square theta, which is sine 2 theta. So here we have sine inverse of sine 2 theta, where this angle 2 theta, it will lie between minus pi and plus pi. Now we have to use self-adjusting property of sine inverse, and for that we'll use the graph of sine inverse of sine x. Now graph of sine inverse of sine x, it is drawn like this. This is 0. This is pi by 2, minus pi by 2, minus 3 pi by 2, and this is 3 pi by 2. Now when x lies between minus pi by 2 to plus pi by 2, this is simply x. We are talking about sine inverse of sine x. Now between pi by 2 and 3 pi by 2, this is minus x plus pi, and here slope is downward, so this is minus x, and this point is minus pi, so it will be this minus x minus pi. So depending on value of 2 theta, we'll have 3 separate intervals. So it will be minus pi minus 2 theta when 2 theta lies between minus pi and minus pi by 2. Now when 2 theta lies between minus pi by 2 to plus pi by 2, it is simply x, which is 2 theta, and when 2 theta lies between pi by 2 and pi, in that case it will be pi minus x, which is pi minus 2 theta. Now theta here is tan inverse of x, so we can write this as minus pi minus 2 tan inverse x, and this is when theta lies between minus pi by 2 and minus pi by 4. So this is minus pi by 2, and theta is tan inverse of x, and this is minus pi by 4. Now this is 2 tan inverse of x, and here theta will be between minus pi by 4 and plus pi by 4, and this is pi minus 2 tan inverse of x when tan inverse x, we have already included pi by 2 here, we'll discard it here, so it will be less than, and then tan inverse, and this is pi by 2. Now we take tan, this is minus infinite, which is always true, so we'll get x is less than minus 1. This is when x lies between minus 1 and plus 1, and this is when x is greater than 1. So sine inverse of 2x upon 1 plus x square, it can be expressed as minus pi minus 2 tan inverse of x when x is less than minus 1. It is 2 tan inverse x when x lies between minus 1 and plus 1, and it is pi minus 2 tan inverse of x when x is greater than 1. Now let it be this function fx. Now f minus 1 negative, it will be minus pi minus 2, and tan inverse minus 1 is minus pi by 4, so it will be this minus pi by 2, and f minus 1 equals f minus 1 positive, it will be 2 into tan inverse minus 1, which is minus pi by 4, which is minus pi by 2. That means this function is continuous at minus 1, and at 1 f1 negative is 2 tan inverse 1, and tan inverse 1 is pi by 4, so it will be this pi by 2, and f1 positive, it will be pi minus 2, tan inverse 1 is pi by 4, so it will be this pi by 2, and f1 is also this value. So it is continuous at x equals to 1. So this function fx, it is continuous in x belongs to R. Now if we find f dash x will be minus 2 upon 1 plus x square when x is less than minus 1, and will be 2 upon 1 plus x square when x lies between minus 1 and 1, and again it will be minus 2 upon 1 plus x square when x is greater than 1. Now left hand derivative, f dash minus 1 negative, it will be minus 1, and f dash minus 1 positive, it will be plus 1. So it is not differentiable at minus 1. In the same way, f dash 1 negative, it is 1, and f dash 1 positive, it is minus 1. So it is not differentiable at 1. So this function sine inverse of 2x upon 1 plus x square is not differentiable at x equals minus 1 and x equals plus 1.
We are given a function fx which is sine inverse of sine pi x. Now write the values of the following. Now what we'll do is we'll draw the graph of sine inverse of sine pi x, and for that we'll draw the graph of sine inverse of sine x. Now this is pi by 2 and this is minus pi by 2. This is pi, 2 pi, 2 pi and 3 pi. This is pi by 2, 3 pi by 2 and 5 pi by 2. Now this is the graph of sine inverse of sine x. If you have to draw the graph of sine inverse of sine pi x, we have already discussed it in transformation of graphs, that all we need to do is we just have to divide everything with pi. So here it will be 1 by 2, this one is 1, this is 3 by 2, this is 2, this is 5 by 2, and this is going to be 3. Now we need to find the value of f 2.7. Now 2.7, it will lie in this region, and in this region we have to find equation of this line. Equation of this line will be minus pi x, and then this graph, it is going to intersect at 3 pi. So when x lies between 2.5 and 3.5, in that case this fx, it is defined as 3 minus x into pi. Now we need to find the value of f 2.7. Now f 2.7 will be 3 minus 2.7 pi, which is 0.3 pi. You can also find the equation of this straight line using coordinate system. So this point is 5 by 2 comma pi by 2, and this point here is 3 comma 0. Now using 2-point form, we can find equation of this straight line. Answer to this first question is this is 0.03 pi. Now we differentiate it. We'll write f dash x, and f dash x will be simply minus pi. So at 2.7, its derivative will be simply minus pi. Now we need to find value of this integral from 0 to 2.5 fx dx. Now from symmetry, these two integrals, they'll cancel out. The only integral value that we'll have is this triangular region, which is 1 by 2 into, now this is 1 by 2 and its height is pi by 2. So it'll be simply pi by 8. And fourth one is the smallest positive x at which derivative does not exist. So this function is not differentiable at this point. So the smallest value is at x equals 1 by 2. So here this one is going to be x equals 1 by 2. So answer to this question is 0.3 pi, minus pi, pi by 8 and 1 by 2.
Now here the question is, we are given this function fx, which is greatest inner function of x plus square root of fractional part of x, and we need to find its continuity and differentiability at all integer points. Now say we are going to find its continuity and differentiability at n. Now f n positive, it will be this limit x tends to n positive, greater function of x plus square root of fraction part of x. Now we let x as n plus h, so it will be this limit h tends to 0 positive, greatest linear function of n plus h plus square root of fractional part of n plus h. Now greater function of n plus h is simply n. So it will be n plus, and then we know that fractional part of n plus x is fractional part of x if n is an integer. So it will be this under root of fractional part of h, and when h tends to 0 positive, fractional part of h is simply h. So it will be this limit h tends to 0 positive n plus under root h, and if you put h as 0, it will be n. So left hand limit at n, it is n, and if we find its left hand limit, it will be this limit x tends to n negative greater function of x plus under root of fractional part of x. Now we let x as n minus h. Now we can write this as limit h tends to 0 positive greatest real function of n minus h plus under root of fractional part of n minus h. Now this is limit h tends to 0 positive. Now greater function of n minus h is n minus 1 plus, and this is fractional part of minus h, and fractional part of minus h is 1 minus h. So it will be this limit h tends to 0 positive n minus 1 plus under root of 1 minus h. If we put h as 0, we'll get this as n minus 1 plus 1, which is n. Now if we find value at n, fn will be greater function of n plus under root of fraction part of n. Now fraction part of n is 0, and greater function of n is simply n. So in this case, fn negative is equal to fn positive, and that will be equal to fn. So this function is continuous for all integers. Now we'll find its differentiability. Now if we find f dash n positive, it will be this limit h tends to 0. Now f n plus h will be greatest in the function of n plus h plus under root of fractional part of n plus h minus n upon h. Now this is limit h tends to 0 positive. Now this is n, and n minus n will cancel out, and this is under root of fractional part of h upon h, which is limit h tends to 0 positive. Now under root h upon h, which is 1 by under root h, and as h tends to 0, it approaches infinity. That means this function is not differentiable at integer points. So this function is continuous for all integer points and not differentiable at all integer points. So answer is A and D. Now perhaps easiest way to solve this question is using graphs. So what we'll do is we'll draw the graph of fx equals greatest integral function of x plus under root of fractional part of x. Now we'll start with this graph, y equals under root of fractional part of x. Now we know that fractional part of x, it is a periodic function whose period is 1. So what I will do is I'll draw the graph of y equals under root of fractional part of x between 0 and 1. And we know that between 0 and 1, fractional part of x is simply x. So that means we just have to draw the graph of y equals under root x. That's the graph of y equals under root of fractional part of x. This is 0, 1, 2, 3, minus 1, minus 2, and this value is 1. Now we have to draw the graph of y equals greatest integral function of x plus under root of fractional part of x. Now if x lies between 0 and 1, then in that case greater function of x will be 0. So it will just be this graph, which is same as y is equal to fractional part of x. Now when x lies between 1 and 2, greater function of x will be 1. So it will be 1 plus under root of fractional part of x. So this fractional part x graph, it gets shifted by 1 unit along positive y-axis. Now previously it is between 0 and 1. Now it'll be between 1 and 2. So it'll connect right here and it'll go from 1 to 2. Between 2 and 3, get a function of x, it'll be 2 and then 2 plus under root of fraction part of x. So this graph, it'll be shifted 2 units upward. So from 0 to 1, now it'll be from 2 to 3. So this is how this graph will be connected. So if we keep joining these graphs, we'll get this graph, and that is the graph of y equals greater function of x plus under root of fractional part of x. Now clearly this function is continuous at all integer points, and it is not differentiable at all the integer points. So again, this answer is A and D. So we have solved this question much easily and quicker using graphs.